Okay, this section is about the organization of the periodic table and the trends that exist as we compare various elements. All this really is based on the electron configuration that each element has. So many of the answers in this section are pretty straightforward. As we scroll down to look at some of these next questions, one of the things you need to remember that valence electrons are the electrons in the highest occupied or outermost energy level. For example, nitrogen, its complete electron configuration is 1s2, 2s2, 2p3. So even though it has a total of 7 electrons, there are only 5 valence electrons in its outermost energy level, which is the second energy level. The number of electrons available for bonding, which they ask about here in number 22 with oxygen, that's just another way to say valence electrons. Scrolling down a bit more, it's important that we know the definitions of atomic size, electronegativity, and ionization energy, and the trends that exist on the periodic table. Basically, size of atoms increases down and to the left, but the valence electrons of large atoms are far away from the attractive forces of the nucleus, so electronegativity and ionization energy decreases towards the bottom left corner of the periodic table, but increases toward the top right of the periodic table where atoms are small and the nucleus is close to the electrons that it's trying to attract. Remember, a good way to help you remember these things was when we learned how to dance. So hopefully that's a good trick to help you remember. Finally, number 30. As we look at this question, this is a great example of a performance task type problem that you might be asked on the final. It requires you to look at some data and answer some more straightforward questions, but also requires you to do a lot of predicting, explaining, justifying, things like that. Two important things to notice about this data table. The first one is that the ionization energy, as you move down each column for atoms W, X, and Y, they decrease no matter which column, no matter which ionization energy we're talking about. Whether it's I1, the first ionization energy, I2, the second ionization energy, all the way across to I4, all these ionization energies decrease as you move down the column. So if you remember that ionization energy is the amount of energy required to remove an electron, that means it's easier to remove these electrons as you move from one atom to another, from W to X to Y, as you move down that column. So that way we know that these atoms must be in the same group, because these atoms must be getting smaller as you move down the vertical group or column. The second thing is, for each of these elements, there's a big jump in ionization energy between the second ionization energy and the third ionization energy. You can see that for all 3 elements, W, X, and Y. This means that it must be pretty easy to remove the first 2 valence electrons, but much, much harder to remove the third valence electron. This would indicate that all these atoms have 2 valence electrons and, again, are in the same group. In this case, the group with 2 valence electrons are the alkali earth metals. So I'll scroll down bit by bit here so that you can have a chance to look at the answers to each of the parts to this question. And hopefully that's a good review of some of the things in our section on the periodic table and periodic trends.